Lying at a height of 60 meters above the ground, the string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. So here, let me take this as a base. Okay. So here, this is a kite somewhere here. Right, a kite is flying at a height of 60 meters above the ground. So the height is 60 meters. The string attached to the kite is temporarily tied to a point on the ground. Let me take this as a point on the ground. So here you will find that there is no slack in the string. So this is a straight line. You need to make an assumption that this string is a straight line, right? So here again, height perpendicular, and what is the inclination given here? With the ground 60 degree. The inclination made by the string with the ground is 60 degree. Okay, so find the length of the string. So we need to find this length. If you name it as A, B and then C, you need to find AC, the length of the string. So again here 60 degree, the inclination angle is given with reference to this 60 degree. This is your opposite side and this is hypotenuse. Then what is the ratio here? What is the ratio of opposite and hypotenuse? Your sine theta. So take sine theta is equal to opposite BC divided by adjacent AC. Sine theta is 60, so sine 60 is equal to BC, that is 60 meters, divided by AC, that is our required length. Now substitute the value of sine 60. What is sine 60? Sine 60. So sine 60 is root 3 by 2. Root 3 by 2 is equal to 60 divided by AC. Now cross multiply. So if you cross multiply, you will get AC is equal to 60 into 2 divided by root 3. So which is equal to 120 divided by root 3. If you want to rationalize the denominator, root 3 which is equal to 120 root 3 divided by root 3 into root 3 is 3. If you want to simplify, 3 ones are 3 fours are, you will get 40 root 3 meters. 40 root 3 meters is the length of AC. Fine. Next one. So till question number 5, you had direct questions. You need to just find a right angle triangle, use the ratio and find the required side. So but here it is a bit different, okay, from the previous questions. Again, the triangle and the ratios will remain same, but how to interpret the given data and get these right angle triangles is important here. So let me read the question. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So this is base, and let me take a 30 meter tall building here. So here the height of the building is 30 meters and name it as AB. Okay, some boy is standing here, okay, and then height 1.5 meter tall. So his height is 1.5 meters. The angle of elevation from his eyes, okay, the angle of elevation from his eyes to the top of the tower, right, increases from 30 degree. So initially he is at this point, let me take it as point C. When he is at point C, so his inclination angle is this. What is inclination angle? Angle made by this line with the horizontal. This one is important here. Actually, what is the ground here? Ground is A to C, but you need to take the inclination with this horizontal line. You can name it as TE. Okay, so this is 30 degree when he is at point C. So here, as he walks towards the building, the inclination increases to 60 degree. The inclination increases to 60 degree. So second position will be somewhere here. When he is at this point, his inclination will be 60 degree with the horizontal, right? So this is the given data, right? So from the given data we got this figure here, and what we need to find here, find the distance he walked towards the building. So you need to find the distance he walked towards the building, that is this distance. So you need to take this as x, right? So now how to find x here? Again, triangle, you need to take this as a right angle triangle. Okay, first get the triangles A, B, C, D, E and then F here. Okay, see here, the total height, that is from B to A, the total height B to A is 30 meters. The total height of the building B to A is 30 meters, and then we know that the height of the person, right, a boy, is 1.5 meters. Then this A is also 1.5 meters, yes or no? A is 1.5 meters. Then what is BE? BE will be the total length 30 minus 1.5, which is equal to 28.5, right? So if you take triangle BEF, right? So take a triangle BEF where it is right angle at E. So as we have a right angle, or as BEF is a right angle triangle, we can use trigonometric ratios here. So which side we need here? We need this A to C here. First try to understand. The required data is distance traveled by boy from point C to this point. Let me take it as F. Okay, or we have F here, let me take it as G. We need to find the distance traveled by the boy from point C to G. Now how to find this CG here? To get this GC or CG, first you need to find A to C. Okay, A to C minus A to G. Try to understand, this one is important. So from this we will get the remaining part of the solution. So first what we need here, we need this GC. How to get GC? The total length, that is from A to C, AC, the total length minus this part. Okay, that gives the remaining part, that is GC, which we took as X. So now let's find this AC and then AG, then you will get GC. So first AG, and we know that these two are horizontal lines and they are parallel, then definitely this AC or this AC is equal to ED, AC is equal to ED, and then AG is equal to EF. Okay, because when you take these two right angle triangles, you won't get AC and AG, you will get ED and EF. Understood? Now let's find this ED and EF. So in this triangle, the first triangle BEF, if you want you can just take the triangle out. Let me draw it here. Okay, BEF, right angled at E, and this is 60 degree here. And then how much we got? BE, we got BE as 28.5. Now find EF. So with reference to this angle, this is opposite and this one is adjacent, then what is the ratio of opposite and adjacent? That is our tan. So tan 60 is equal to 28.5 divided by adjacent, that is EF. So tan 60 root 3 is equal to 28.5 divided by EF. So if you simplify this, you will get EF is equal to 28.5 divided by root 3. Okay, so keep this 28.5 root 3 as it is. No need to rationalize or take root 3 as 1.57. Don't do that. Okay, keep this as it is, 28.5 divided by root 3. So we got EF here. So next we need ED. So here we have this ED. So again take a triangle out of this figure, B to E and then E to D, and the angle is 30 degree. So here B, E and then D. So this is the second triangle, right? The second triangle from the figure. So here B will remain same, which is equal to 28.5, but this ED will change. So now we need to find this E to D distance. Again opposite and then adjacent with respect to this angle. Take tan 30. What is tan 30? Opposite 28.5 and then adjacent ED. Tan 30 is 1 by root 3 is equal to 28.5 divided by ED. If you cross multiply, you will get ED is equal to 28.5 root 3. Okay, again keep this one as it is, 28.5 root 3 is your AD, right? So next, let me do this part. So here you got EF and then ED. Next, what we need? We got E to F and then E to D. We need GC, and we know that GC and FD are same, or GC can be written as the whole length ED minus EF. Okay, so GC and these two are same. Now get the difference. What is ED? 28.5 root 3 minus 28.5 by root 3. Okay, the simplification part is important here, because most of you guys are not comfortable with the operating irrational numbers. So here just stick to your fraction, subtraction or addition, right? So here the denominator is 1, so then LCM is root 3. Now cross multiply 28.5 into root 3 into root 3, because we have one denominator 1 here. You need to multiply this with root 3, then you will get 3 minus 28.5. So this gives, so here now how to simplify this one? Instead of multiplying these two, can I take 28.5 common? 28.5 common, then you will be left with 3 minus 1, and in the denominator same root 3. So 3 minus 1 is 2. 2 into 28.5. 2 into 28.5, or you can keep this 28.5 into 2 as it is, and then root 3. Now multiply root 3. So what you will get? Rationalizing the denominator. So here after simplification you will get 57 root 3 divided by 3, and if you simplify this further you will get 19 root 3 meters. Okay, so this is the required length, the distance traveled by the boy from T to F, that is our x. So x is equal to 19 root 3 meters. of elevation of the bottom and top of a transmission tower fixed at top of a 20-meter high building is 45 degree and 60 degree. Find the height of the tower, right? So now here we have tower, (20-meter high building), two inclination angles, right? So how to interpret the data is again very important here. So from a point on the ground, let me take a base or a ground here. From a point on the ground, so let me take this point. The angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building. So we have a building here. Okay, so this is your 20-meter high building, and on top of this there is a tower. Okay, on top of this there is a tower, right? So from this point, the angles of elevation of the bottom and top of a transmission tower, take 2 points, point 1 and point 2. Okay, so here simple logic. So which one is greater angle here? So this is greater, so you need to take this as 60, and this one is the smaller angle, you need to take this as 45 degree. Okay, one from the bottom and one from the top of the tower, right? The height of the building is given 20 meters. Find the height of the tower. So we need to find this height. What is the height of the tower, right? So this is the given data. So again, this can be solved using the trigonometric ratios. Before using trigonometric ratios, we need two right angle triangles here, or we need to take two right angle triangles, right? So taking those two right angle triangles is very important here. So what are those two triangles? Before taking triangles, let me name some what as. I will take this point as A, this point as B, and this point as C, and then this one as D. Okay, so if you simplify this, you will get this figure. Okay, A and B somewhere here, and then C, and then D, right? So again, this is your 90 degree here, this is 45, and this one is 60, and we need to find this AB, right? We need to find AB. So now how to find AB? How can we get this AB here? So for that, first take two triangles. What are the two triangles you will take? Get two right angle triangles from the given figure. So the first one is ACD, triangle ACD, and the second one is triangle BCD. Your first job is to get two triangles or get all the right angle triangles from the figure. So here we have two right angle triangles, so I took those two here, and then let me draw them. What is ACD? This is your ACD. Okay, so here AC and then D, and then what is the angle here? ACD 60 degree. This ACD is 60 here, and then BCD. Okay, so here 30 degree, sorry, 45. You have 45 degree. This is your B, C, and then D, right? And the height of the building is given, so this is 20 here, right? And what we need? We need AB. We need AB. How to get AB? AB is equal to the whole length AC minus this BC. Yes or no? The whole length AC minus BC will give us this required AB. BC we know, the length of BC is 20 meter. So our job is just find the AC. Okay, you need to just find the AC. Now how to find this AC? Okay, how to get this AC? So here we have this AC here, we have this AC in this triangle, yes or no? We have AC in this triangle ACD, but we can't find this AC, right, from the available data, because we have 60 degree here. We need at least one side to find this AC, so that side CD can be found from this triangle, because we know 20, that is length of BC 20, and then angle, and we need this CD. Again, what is the ratio of opposite and adjacent? Tan. So tan 45 is equal to opposite BC divided by adjacent CD. Tan 45 is equal to opposite BC divided by adjacent CD. Tan 45 is 1, and what is BC? 20. CD we need to find. If you cross multiply, CD is equal to 20. Yes or no? Okay, 20 meters. So this CD is 20 meters. So if CD is 20 meters, now you can find AC. So again, opposite by adjacent, tan 60, opposite is AC, and then adjacent is CD. So tan 60 is root 3, and AC we need CD is 20. If you cross multiply, you will get AC is equal to 20 root 3. Fine, you got AC is equal to 20 root 3. Now your AB can be written as AC minus BC. Now substitute the values. 20 root 3 minus 20. If you take 20 common, then you will be left with root 3 minus 1 meters. Okay, so this is the height of the tower. 20 into root 3 minus 1 is the required height of the tower. Okay, so given data, figure, simplified figure, and then two triangles, and then tan ratio. Okay, thank you.